I want to talk a little bit about developers love CICD, the second ops sequel. It's kind of a snatchy title, but we will get into it. The thing is a little bit about what I'm going to touch in the next 20 minutes, roundabout a little agenda, a short introduction. Then we're going to dive a little bit into CICD, the second ops, what's in the pipeline, going even more deeper down in the pipeline and optimizations, defining some team actions and cultural changes, maybe asking ourselves, are we safe? This is kind of a spoiler, what's coming. And later on, also asking the question about auto DevOps. A little bit about myself. My name is Michael. I'm originally from Austria. I moved to Nuremberg around about 8 years ago and joined GitLab as a developer evangelist in March this year. So it's around about 7.5 months now. I'm doing everything around monitoring, observability, infrastructure as code, writing blog posts, social media, and things like that. So if you want to reach out, you can find me as DNS Michi on social media and also on gitlab.com. If I'm not engaging on social, I do love build Lego models and have some coffee chats with my friends, talk about the latest tech. This is about me. About GitLab, just to highlight a few numbers, GitLab was founded in 2014. The company exists even longer. And I know, Christian, you're missing Rashid Hixi. Just hit me up with your address. I might send you some. Coming back to GitLab, the thing is, you can use it for the entire software development lifecycle. It's a huge feature set. You can self-host it in the cloud, offline, whatever you want, and speed up your development lifecycle. And today I want to dive a little more into how CI/CD evolved over time and how development, security, and ops engaged with it. The thing is, and I read that in a Forrester report lately, we kind of changed our development model. So the speed to market is important. You need to release often, you need to release fast. And the faster you are, the more probably your product gets adopted, like TikTok or something else. And later on, you might build up some quality processes, add security, add monitoring, and things like that. So it's kind of a fast build, measure, learn feedback loop. And you kind of need to work with it. So the thing is, and this is a screenshot or an experience of myself, when I started with CI/CD, everything was red and nothing did work. So there were kind of a few iterations necessary to adopt and say, hey, the pipeline is working now, the tests are in a good shape, and everything is fine, and I'm probably never touching it again because it works. Thing is, others might experience the same problem, and there is lots of trial and error involved, and you don't know about the best practices, and sometimes you read a blog post. It's, yeah, oftentimes you might experience long pipeline run times, the feedback loops are blocked, so the reviews cannot happen, and there are many things where you can think about optimizing your CI/CD pipelines coming from a developer view, and maybe you're being asked, well, please fix the CI/CD pipelines because, well, and you're gonna go there and say, why should I fix them? Yeah, because they consume so many resources. So probably they're running in the cloud and the AWS bill is exploding, or maybe the local storage is being drained by I/O caused by the CI/CD pipelines. And then they say, well, I'm just like the developer, I just want to run my tests. I have no idea how this works, and I kind of build it up. And how would I approach this problem? Yeah, maybe just read the docs or ask the community, because everyone has something to share, and probably there are best practices around. And this leaves you, or could leave you, with an uncertain feeling. So the thing is, how can we approach this? Oh, there's the Easter egg, by the way. We want to look into a pipeline, especially when we want to look from the surface, from a developer's view. Oftentimes, you want to just identify the pipeline duration. So you want to know how long does it take for the CI/CD pipeline to execute. So how long would it take to get feedback out of it? And keeping in mind the minimum and maximum pipeline duration. Another thing to keep in mind is to look at the number of stages and jobs involved to get an idea where optimizations can be used. And a third thought would be incorporating dependencies and sync runs, because oftentimes you might build something which runs in parallel and asynchronous, super fast, but super hard to understand and optimize later on. Another thing to keep in mind are patterns with failed jobs. So when you have some flaky unit tests and in 1 second they work and in 5 seconds they don't work again, and you have no idea what's going to happen. So this is something to keep in mind. Sometimes the test coverage drops for some reason. Also an interesting point to monitor. And around the infrastructure, there might be build dependencies involved. There might be containers in the sandbox environment. You might be running something into some problems with network latency, low-level VPNs involved. Maybe you even buy traffic and you wonder about the builds and want to optimize that. And last but not least, security is also a thing which might influence things in there. So when we start looking into kind of optimizing CI/CD pipelines, one idea could be probably the tool of your choice. Could be GitLab, could be GitHub, something else. Has an analytics overview, and you get a crisp idea about the duration of your jobs. And the screenshot on the right-hand side says there's a job which runs 7 minutes, which is rather long. If I want to have fast feedback, I might want to be looking into this. The other portion to immediately look into is like failure success, and get an idea. Why are there so many failed jobs? Is there like a pattern involved? How does this evolve over time? And getting some trending and some reporting out of that, just to get an idea of where to start looking. The other thing is, and this is a customization of yourself, because each programming language might need different approaches. You can run unit tests. You can get the feedback in your merge request, pull request, on every push, on every commit, whatever is needed. It's super nice, it's super convenient. You can integrate it into the merge request, you get an output, and you can probably start working rather easily. The thing is, this is something also to watch and keep in mind in terms of optimizations, also flaky unit tests, analysis, and so on. Last but not least, we might have different visualization layers, just because the staging or the stages and the pipelines are looking like they're in a good shape. Everything is green, but from a quick glance, you cannot really say, well, what is the critical path in there? Is there something running asynchronously? Whatever comes to mind. And maybe the critical path is, for example, in the picture below, or in the screenshot below, you really want to like format the code. We want to run some tests. Later on, we compile the code, and then we're going to run it. Maybe this is the critical path. So there are specific toolings and layers where we want to like see what the CI/CD pipeline is doing. Now, when we go a little deeper into the pipeline, and this can get quite complex. So the thing is, as a developer, I might need to find my operator or my sysadmin head right now and say, hey, maybe I'm looking at a little more from the monitoring perspective, and I want to get the global picture. I want to check the workloads, bottlenecks, resources being involved, everything which can help me understand how this CI/CD pipeline works, how many resources are being attached to it, and then later on suggest changes and discuss actions within your teams or team, because you maybe want to refactor the pipelines, becoming more efficient, and you also want to reduce costs because the computing powers in the cloud are exploding and other things where you just probably make your manager or your other teams happy with just a small change of, for example, using auto-scaling with CI runners and just shutting them down on the weekend because no one deploys on the weekend, maybe. In case you want to go deeper into the monitoring level and like having a visualization around CI pipeline or CI/CD pipelines, a good way or good idea would be to add that to your existing monitoring system, Probably you might already have Grafana and Prometheus around, or like Nagios, Alzinga, Sensu, Zabbix, whatever comes to mind for your monitoring. And you can immediately visualize, for example, CICD pipelines via REST API access. The screenshot shows an example how to use an existing GitLab CI pipelines exporter and incorporate it into a Grafana dashboard. 27 minutes in the screenshot for pipeline duration is pretty not so good. This is probably something to look at, and you can immediately see that, like in the Office dashboard, getting an idea and saying, hey, something is weird, and we need to start looking into that. And there's also a check plugin, which I will be sharing the slides later on. Another thing to look at, the resources. This is like lots of things to unpack, many ideas to look at. Storage consumption can be a thing in your CI/CD pipelines, especially when your jobs generate binary assets stored as artifacts. They might be kept on the storage forever. So you are kind of keeping terabytes of artifacts which you don't use anymore. And the lookup and the index explodes, and like the normal runtimes for the CI/CD pipelines are getting slowed down. So looking at them and like purging and expiring the artifacts is a good thing. The other thing which could influence your storage layer as a whole are container registry images. So if you're using Docker containers or Podman containers or whatever format you prefer, there might be a certain chance to keep everything forever as well, and optimizing the storage and also optimizing the container image is a good thing. The other portion to keep in mind is the network traffic. Like I said before, when you're on a low latency connection, or maybe you're even paying for the VPN between the US and Europe. I know someone who does. This might get quite expensive if you're pulling lots of data all the time, and it's like the CI jobs are installing the dependencies all the time. Super convenient because you have the same environment all the time. But on the other side, it just pulls in like apt-get install build essential 200 megs or whatever is being pulled in from reverse dependencies. This can generate quite a lot of traffic. And on the other side, huge Docker images, just because you probably just want to have a single Docker image for all your different languages and CI toolings and other things. Super convenient. But when the image is 10 gigabyte or 20 gigabyte, this also might incorporate lots of traffic and slow down your CI/CD pipeline in the long run. Last but not least, everything which comes to mind from host monitoring, or like Linux, macOS, Windows, Unix flavored hosts. The CI runner might take disk I/O. You can monitor CPU usage, and you might even look into your CI jobs and have some sort of job tracing involved, collect the data and integrate it into your merge requests, for example. So there are many ways to actually look deep down into the CI pipeline. And actually, I'm now not a developer anymore. I'm just more of like the monitoring sysadmin. But this is something to unpack because you might know how to optimize your CI/CD pipelines. One other point in regard of merge requests is you want to use them for fast feedback. So when you're working on a new feature or working on something, you can also incorporate specific things like the test coverage. You can add the artifacts, you get metric reports, the test reports. You might even use code quality analytics, accessibility testing, and also security reports. So whenever there's some automated security scanners around, checking for static application security tests, dynamic application security tests, container secrets, dependency scanning. So there's lots of things to unpack, and you can get everything integrated into your merge request or pull request. Might be done natively, might be done with bots and automating the issue, or the merge request. So there are lots of things to keep this in a central view while you're working on a specific feature. Last but not least, to get quick access when you're like moving the layer out of the merge request and the code and things like that. When you open up a repository and the project, you immediately want to see whether the pipeline is in a good shape and the test coverage is kind of okay. You can use batches for faster state detection. This totally helps to see whether the project is in a healthy condition, and you might not need further investigation on optimizations. Now this was lots of ideas on how you can approach these things and look into them. Maybe you want to define some team actions around this and say, hey, how can we kind of getting things going? What are the things we want to start with? And one thing I always kind of see is, yeah, you probably have the best structured stages in your pipeline, and oftentimes there are jobs which are blocking each other. And one strategy is to say, okay, I want to fail fast. And when the source code is not compiling, like the format job in the example, I want to just fail fast and say, hey, okay, the entire pipeline fails just because the source code cannot be compiled. Otherwise, and this is the screenshot on the left-hand side, code quality is running for 7 minutes, like the screenshot at the beginning. This would block the entire stage for 7 minutes. And then CICD says, oh, I'm broken. In contrast to format, which runs, I don't know, 1 second, 5 seconds, getting immediate feedback and also not wasting resources. The other thing is, and this touches the CICD infrastructure, depending on whether you are responsible as a developer or maybe you have your ops team around managing that. Docker pull or Docker images being pulled could take quite a while if you're going to the CDN or to Docker Hub. This might also be a problem with November 1st when Docker Hub starts to rate limit your connections. This, I kind of expected something breaks then. You probably want to use your own container registry, be it whether it's a GitLab, GitHub, whatever container registry. But you definitely want to create your own Docker images based on existing images. That's possible with the from import, or you might have the option when you're running it, for example, in Google Cloud, there's the possibility to use the Cloud Container Registry nearby. This is a possible way to optimize that. And the other one is, speaking of the CI jobs, which always install the dependencies, you might want to create pre-built Docker images in where the tool chain is already installed, and also think about caching between the jobs, like optimizing the CI/CD pipeline runtimes. And the example or the quote below just mentions that a custom Docker image has just increased PHP dependencies and CI/CD runtimes after all. Last but not least, sometimes it's not about us developers, or like you're seeing a stack trace in the application and you probably have no idea how to fix it as a non-technical person. And this is something which we also see when we at GitLab deploy our blog. We might see some Ruby exceptions, and the idea is to kind of catch them and say, hey, I want to use colored error messages, maybe with an emoji. I want to provide a clear-cut message and also link troubleshooting documentation, for instance, just to allow everyone fixing the pipelines, and not just like saying, hey, it's like the responsibility of this developer because Git blame said that you have changed this line. Everyone should be able to fix the CI/CD pipelines fast enough. Needs documentation, and it also needs to create issues from the findings and encountered learnings, especially because in times where everyone is remote now, it's easier to onboard someone and saying, hey, maybe you want to look at this incident which happened 1 year ago. This is how we fixed it. Now, are we safe? And I think I'm running a little bit out of time. we also want to catch up with security, and security is something interesting because probably you might get asked and say, hey, open source is cool. We want to release our code to the public, or maybe give it to our customers. And you just do it. And at some point you go figure and say, hey, our AWS admin account is doing something weird. And you kind of catch that the test suite has some hard-coded credentials inside. And everyone is like busy and 3 AM at night. You revoke everything, you analyze the source code because there could be some more hard-coded stuff inside, and everyone is like burned out and stressed and angry and things like that. And maybe there's something where we can make our lives easier from. The other thing is, when you have like ensured that your code is safe, you might have forgotten that the CI configuration has some clear text password inside. So you're giving access to someone outside of your organization, and you figure, oh, maybe the MySQL database password has been leaked and now you revoke it. Maybe you have reused the password for different applications to access it. So monitoring was read, everyone is like angry, burnout and things like that. Also not so nice. So this is the cycle where security automation comes in. Luckily, everything is already solved. We just need to learn it. That's the problem. We can, for example, use secret scanning and get an idea, get incidents, get issues out of that. And on the second part, we could, for example, use HashiCorp Vault, automating the way we are getting credentials, which means we get a time-based token and nothing is stored in plain text anymore. So now we're reaching kind of auto DevOps or automating everything. So we are auto build, auto test, trace, scan, fix, suggest, like machine learning. We are automatically deploying everything. And at a certain point, we might just merge everything automatically because, yeah, we are automatically happy. Maybe are we happy? I don't know. The thing is, and this is an interesting thing I needed to learn myself, there are so many changes coming into your main branch and deployments and things like that. You totally need to level up your Git game again. So you need to learn how to Git fetch and Git rebase a rich in main, like rebasing the local branch against the remote. And maybe you also get a lot of AI and machine learning fixes or suggestions. The AI might adopt your design patterns, which probably might be good or not, I don't know. And last but not least, we need to learn lots of things. So there is so much technology coming around, and to unpack, it's a dangerous loop. One thing I learned is like to have tech coffee chats and share what we learn with each other in a kind of coffee chat atmosphere in all remote. But the thing is, there's more coming. So there are some stories and some like snarky comments inside. Well, if, for example, someone says, well, let's increase the test coverage to 100% because we need 100%. I say, okay, yeah, then I'm returning okay for every function, and this is a stop and everything is fine. Actually, it's not, but different story. Making your manager happy because everything is green. The other thing is tracing and open telemetry and getting insights into your applications is super important, and I predict this will be coming in 2021. The thing is, you can make things, things are complicated. So when you're using an object-oriented model and you're putting it into the main object, into the constructor, the tracing function, everything inherits from it, and the application was slowed down by 50%. It's also not a good thing. So we need to go again at the beginning of the presentation and say, hey, how can we optimize? How can we learn? Things like that. The other thing is, maybe you've seen HashiCorp Waypoint last week on Thursday being announced. Super convenient. Let's try this. We can do it. It's not YAML anymore. It's using HCL. Yeah, but maybe we can wrap YAML into HCL now because we just have it. Also, not a good way of doing things. Another snarky comment: why does our app not run in Kubernetes already? Yeah, probably because it's a monolith and we need to rewrite everything from scratch. But we cannot tell our manager So maybe let's go ahead and put everything into a single container, like application, database, front end, whatever. And this is just fine. And everyone is happy because we run it in Kubernetes as a container. So last but not least, the aforementioned machine learning, they are suggesting patches. And this is also something which is coming in the future. Well, maybe the AI is learning from you and the wrong design patterns, because we just did it wrong in the past 5 years. And now CICD is failing again because everything which gets proposed and auto-merged fails. So we are gonna get started again and learn and say, hey, how can we optimize our CI/CD pipeline? We need to identify that AI is failing. And last but not least, fast testing was coming or is coming fast, and it's exploited our production. And then you find out or learn maybe you shouldn't have changed the DNS for DNS record from staging to production for testing, because it's always DNS, you know that, also from my nickname. So yeah, there's many things to unpack, and I think we will be starting all over again with optimizing and learning things. So I'm still pumped up. Sorry for taking too much time. I hope you enjoyed it, and thanks for your attention.